If you've ever felt trapped by a bad habit, or maybe stuck on a skill plateau, or just, wished you could upgrade your default settings,
Then this deep dive is for you.
we are hacking the operating system of the human body, the brain. We're going to get into the research that gives the actual specific instructions for actively rewiring yourself.
And this whole mission, it really just hinges on one core concept.
Neuroplasticity.
Exactly. The brain's fundamental ability to change and adapt throughout your entire life. And we have stacked the sources to give you a genuine understanding of how to leverage this.
Right.
We've compiled findings that challenge the traditional, maybe overly simplistic views of brain recovery. We've combined that with clinical insights into cognitive therapy, the hard science of meditation, the mechanics of motor learning,
And the stuff everyone forgets.
the foundational roles of proper sleep, and of course, targeted nutrition.
Our mission today is to distill all of this into actionable instructions. We're looking at 3 core pillars: action, mental training, and then rest and fuel.
If we understand the rules, we can play the game better.
Okay, so let's unpack this. Let's start with that foundation of action. What is this plasticity thing really doing?
At its core, neuroplasticity is the brain's intrinsic capacity to restructure its connections in response to, well, everything you put it through.
Learning, injury.
Environment, all of it. And when we talk about this restructuring, we're mostly talking about 2 things. Synaptic plasticity.
Which is strengthening or weakening the connections that are already there.
Precisely. And the other one is neurogenesis.
The creation of brand new neurons.
Brand new neurons, right?
Yep.
Which primarily happens in the hippocampus, your memory center.
But if you think you can just, tear down your old brain and build a new one from scratch, some new research suggests you might need to think again.
Yes. This is a major academic challenge to that traditional, almost fantastical view of brain recovery.
It comes from Professors Macon and Krakauer at Cambridge and Johns Hopkins.
And their research really pushes back on this idea that the brain undergoes a wholesale, complete rewiring, or that it repurposes entire unused regions after an injury.
So it's not a blank slate.
Their findings point to a much more efficient system. Instead of a total system overhaul, the brain's adaptation involves enhancing or modifying pre-existing architecture.
So it's tapping into things that were already there.
Exactly. Latent capacities that were present since birth, but maybe were never fully needed or developed.
So it's less about a whole brain region deciding to learn, say, a new language, and more about just turning up the volume on pathways that were already there, sort of waiting in standby mode.
A perfect analogy. They looked at that classic example of increased ability to process signals from remaining fingers after an amputation.
Right. The traditional view was the brain area just got repurposed for something else.
Their reinterpretation is that the brain is simply modifying its existing architecture to better process the signals it is still receiving. It's just optimizing what it has.
Okay, so what's the practical implication here? What does that mean for you, the listener?
It's key. Since the brain isn't magically creating new areas, any improvement, any change requires dedicated learning and repetition.
You have to put in the reps.
You have to deliberately put in the reps. This is all codified in the foundational principles from Kleiman Jones. You need to use it or lose it, specificity, and then the 2 biggest levers.
Repetition matters and intensity matters.
Those are the drivers.
So if repetition is the driver, how do we make those repetitions actually stick? Let's pivot to the most challenging form of repetition for most people.
Habit formation.
Habit formation. We have been lied to for decades by this famous, easily digestible idea that it takes just 21 days to form a habit.
And that's a classic misinterpretation. It came from, of all things, a plastic surgeon's notes in the 1960s about his patients.
It had nothing to do with learning a new skill.
Nothing. The hard data shows that habit formation, it varies wildly. Anywhere from 18 days on the very low end to a staggering 254 days. But if you look at the research, the median time, the middle of the road, to reach 95% automaticity.
That point where you almost never forget to do it
is 66 days.
That 66-day median is such a crucial piece of knowledge. It tells you to expect, a couple of months of conscious effort.
And neurologically, that conscious effort is the most fascinating part of the process.
It's a shift, right?
It is the shift. When you start a new behavior, it's a goal-directed behavior. It requires active decision-making. That's mediated by the ventral striatum.
Which you could call the brain's emotional hub, the reward center.
Right. But as it becomes automatic, a true habit, it shifts. It moves to the dorsal striatum.
The brain's autopilot center.
The basal ganglia moves from conscious effort to automatic processing. It just frees up so much bandwidth.
So does that mean a really powerful, maybe even negative reinforcement can build a habit faster than a positive one? Or is it just the intensity that matters?
It's the intensity.
I mean, studies in rats show a drug like cocaine can speed up that ventral dorsal shift in just 15 days.
It's the sheer intensity and the reliability of the reinforcement that matters most for speed. It doesn't matter if we label it positive or negative from a societal view.
So if the reward, or even the relief in the case of avoidance, is immediate and strong,
The brain shortcuts the learning process. It just encodes that behavior much, much faster.
speaking of efficient encoding, let's look at motor skills. This applies to anything physical learning to dance, recovering a healthy gait after an injury.
This is where the optimal theory of motor learning comes in.
And it hinges entirely on where you focus your attention.
This is a huge takeaway for coaches, for therapists, for anyone learning a skill. The research consistently shows that an internal focus.
Meaning you're directing attention to your own body movements, like tighten your core or bend your knee exactly this much.
Right, that actually impedes both performance and the ability to automate the skill.
So if I'm struggling to learn a golf swing and I'm just obsessing over my left elbow, I'm actually making it harder for my brain to learn it.
Exactly. You are flooding the system with unnecessary micromanagement signals. The opposite is true, an external focus.
Focusing on the goal, the environmental effect of the movement.
Right. That facilitates automaticity, and it requires less conscious effort. You focus on the result, not the mechanism.
I love that. So like focusing on where the golf ball is going to land or where your foot hits a marker on the floor instead of focusing on the mechanical feeling of your knee.
Precisely. They did studies on balance, for example. Participants who focused on platform markers, an external cue, instead of their own feet.
An internal cue.
They had better balance during the task and much stronger learning retention weeks later. Your brain's motor networks just work better when the prefrontal cortex, the planning center, steps back and just focuses on the outcome.
And we can't talk about action without mentioning the most powerful, easily accessible physical act for neuroplasticity.
Aerobic exercise.
Consistent long-term cardio fundamentally rewires the brain. This is not just for heart health.
It's multi-layered. Cardio increases blood flow, which naturally improves function in executive areas like the prefrontal cortex. It helps with planning, decision-making.
And crucially, it promotes neurogenesis.
That new neuron growth, yes, especially in the hippocampus.
And the star player in this whole process is something called BDNF, brain-derived neurotrophic factor.
I think it's best described as high-grade fertilizer for the brain.
That's a great way to put it.
BDNF supports neuron growth, it strengthens synaptic connections, and it leads to greater brain resilience overall.
And the benefits aren't just immediate, are they? They're long-term structural defense.
That's right. Consistent aerobic exercise improves memory, attention, and executive function. And for older adults, long-term cardio slows age-related cognitive decline, including atrophy in areas like the hippocampus.
So it's providing genuine protection against dementia risk.
A very real protection.
Okay, we've covered the physical reps. Now we pivot. Does the same mechanism of repetition work if we're only training our thoughts? Let's shift to directed mental training, starting with CBT.
Cognitive behavioral therapy.
Yes.
CBT is one of the clearest clinical examples of exploiting neuroplasticity. It's a training system designed to help the brain shift from automatic, often negative, emotional reactions.
To thoughtful, balanced responses.
Exactly. Think of it as systematic circuit training for your mind.
So how does that look in the brain? What's actually happening?
Well, the mechanism is pretty simple. Every time you use a tool, like a thought record, to challenge an unhelpful thought and replace it with a more realistic one, you activate a new neural circuit.
And with enough repetition.
You strengthen those new beneficial circuits. At the same time, the old negative pathways that fired automatically are starved of use. They weaken through that use it or lose it principle.
And brain imaging actually confirms this, right?
It does. Consistent CBT reduces hyperactivity in the areas responsible for fear and worry, and simultaneously strengthens the areas involved in planning and emotional regulation.
So techniques like breaking down a fear into tiny, manageable steps.
Gradual exposure, yes. You are literally building new, stronger highways in your mind.
And we see similarly dramatic structural changes with other kinds of mental training, like meditation.
We do. The focused mental effort physically remodels structures. The classic proof of concept for this is the London taxi drivers.
Right, their hippocampi physically changed, they grew larger just from memorizing the city map.
A purely mental feat causing physical growth in the brain. It's incredible.
So what exactly is meditation doing to the brain's structure?
Meditative experience is strongly associated with increased gray matter density and cortical thickness. For instance, in the right anterior insula.
And that's the part of the brain
For interoception. It's just a fancy word for sensing the internal state of your body. Your heart rate, subtle feelings. You just get better at observing yourself.
Okay, what about aging? Can meditation counteract the natural thinning of the cortex that happens over time?
It appears so. One compelling insight showed that the cortical thickness in older meditators, particularly those in the 40 to 50 age bracket, it often matched that of much younger non-meditators, 20 to 30-year-olds. It suggests that consistent practice may actually slow age-related cortical degeneration.
So it's not just a coping skill, it's literally structural maintenance for your brain.
Absolutely. And it affects not just the gray matter, which is where the processing happens, but also the white matter.
The information highways that connect the regions.
Right. And even short-term training, we're talking 11 hours over a month, can increase the efficiency of those white matter pathways.
Wait, how do you even measure white matter efficiency?
They measure it using something called fractional anisotropy,
Okay.
which is essentially a fancy way of saying they check how organized and fast the connections are, and they found increases in the efficiency of those connections in areas like the anterior cingulate cortex.
A region crucial for self-control and decision-making.
Exactly.
Okay, so we've covered the action, the physical reps, and the mental training, the thought reps. We now have to move to the critical third pillar.
Rest and fuel.
If the first two parts are about building, this third part is mandatory for maintenance and recovery.
And this is where we need to talk about sleep, and specifically the synaptic homeostasis hypothesis.
That sounds complicated.
It's the core mechanical reason we sleep. During your wakefulness, during learning, every experience, every piece of information you take in increases synaptic strength.
So all your connections are turned up to max volume?
They are. Scientists call this synaptic potentiation.
So it sounds like sleep is mandatory defragging for the brain, like clearing the RAM. If wakefulness is turning up every single volume knob in the brain, sleep has to come in and reset the master volume.
That's a perfect metaphor. Sleep is characterized by synaptic downscaling, and you need this for two essential reasons.
Okay.
First, it returns the total synaptic weight to an energetically sustainable baseline. Your brain uses a ton of energy during the day.
The metabolic evidence for this is clear, right?
Very clear. Cerebral blood flow is nearly 20% higher after a day of being awake than after you've had a night of sleep.
So if you don't scale back, you just run out of bandwidth and energy for new learning the next day.
Exactly. And the second reason is learning itself. By proportionally reducing the strength of all synapses, the brain effectively prunes the weakest, least important connections.
It increases the signal-to-noise ratio.
It does. The strong, important memories remain strong relative to everything else, while the weak, irrelevant noise gets eliminated. You can't learn more tomorrow if you don't prune what you learned today.
And finally, we need the material science of nutrition to fuel this whole operation.
Diet is absolutely foundational. Your brain is largely made of fat and water, omega-3 fatty acids.
ALA, EPA, and DHA.
Yes, from sources like fish, flax seeds, walnuts. They're absolutely integral for creating stable cell membranes and supporting high-quality synaptic plasticity. Your brain literally cannot rewire itself without these fats.
And then we need the raw materials for messaging, so amino acids.
Correct. Amino acids are the direct building blocks for our crucial neurotransmitters. We need tryptophan for serotonin, which regulates mood,
And tyrosine for dopamine.
which is essential for motivation and concentration.
And because the brain is so energy intensive, it generates a lot of sort of metabolic exhaust for byproducts.
It does, which makes it vulnerable to oxidative stress.
Yeah.
And that's why micronutrients matter so much.
So antioxidants.
Antioxidants like curcumin and turmeric, and the ones you find in cocoa and green tea, they help combat that stress and protect neural tissues. B vitamins are also just non-negotiable for energy metabolism and neurotransmitter function.
This has been an incredibly integrated synthesis of performance. So to summarize for you, the listener, rewiring your brain requires specific, repeated action.
Using external focus and consistent cardio.
It requires intentional mental training.
Right. like CBT and meditation to restructure your circuits.
And finally, it demands structured rest and fuel.
Optimizing sleep for that crucial downscaling and providing high-quality fats and micronutrients.
Right.
Before we wrap up, it's worth reflecting on the powerful implication of the anxiety cycle we saw in the sources. It's the perfect negative example of neuroplasticity at work.
Okay, what's the cycle?
The cycle is anxiety leads to avoidance, which results in survival and a feeling of relief,
And that relief, that feeling of safety, acts as a powerful reinforcement.
which leads to increased anxiety in the future. The pathways of fear are strengthened by the simple repetition of avoiding the thing you fear.
So what does this all mean? The final provocative thought we want to leave you with is this. If the act of avoidance literally strengthens the neural pathways of fear through reinforcement,
And we know that neuroplasticity is relentlessly driven by repetition.
then the single most powerful and really revolutionary shift you can make is to replace avoidance with willingness.
That one single choice.
That single choice to engage in an action, even a tiny, uncomfortable one, is where you actively begin the work of dismantling the old, unhelpful wiring and creating a more resilient future.